Assalamu alaikum. Welcome to our fourth experiment in electric machines lab. Today we'll be plotting a characteristic for a no-loaded separately DC generator. And as you know, we have two types of stations. We have the black one, which is a sun. We call it sun station, and feedback station. So we'll start with explaining how we can plot this characteristic and do the experiment using the sun station. Before to do so, let's talk a little bit about the characteristic itself. So the magnetization characteristic, okay, it represents the variation of the generated voltage across the armature of the generator. So that's the generator section, okay, versus the excitation, not the field current for this field winding here, okay, for the generator. So as you know, in the lecture, this characteristic, once we start from zero, the voltage, generated voltage at the armature will be zero, of course. And as soon as we increase this field current, the voltage will be following a linear path, okay, till a certain value of field current. The variation will be small, okay, and we reach, for that case, we reach the saturation part. So now, after we reach that part, what you can do, we can just reduce from this point here, go back to zero, so reduce the field current from this maximum value and going towards zero, back to zero. But the characteristic will follow another path, okay, where once we reach zero field current, the voltage will be the voltage generated across the armature will be different than zero, and this is because of what you call residual magnetism inside this the armature. So going forward from zero toward the maximum value that we can reach, where we have saturation in terms of current, maximum of the current and saturation for the generated voltage. And from that point, we go back. So one, we do this experiment like this, one here, forward. And once we reach this point, we go backward like this. This is two, or step number two, and this is back, okay, word. This is A here, okay. We go backward towards zero. So going backward towards zero, the characteristic will follow another path and will end up by a certain value here, which is different than zero in terms of voltage across the armature. So that's the experiment to be done today, inshallah, using this sun station. Now, the experiment itself will be done using those equipment. So we have the motor. So this is our motor here, DC motor, and DC generator. The other side. Okay, they are mechanically coupled here. I'll show you the photo after from the side. Another view where you can see the mechanical coupling between those two machines. We'll be using a tachometer to measure the speed of our system or generator or motor. So we need the tachometer. Okay, this is portable tachometer. Also, we have a fixed tachometer, which is this equipment here. Now, to excite either the motor or the generator in terms of field winding, we need the variable DC. Okay, so the first variable DC for the motor, because we need to start from 0 RPM toward the rated speed of the motor or generator. Okay, so one of them. So we'll check the speed after. I think the speed it's written in this nameplate here. We'll check it after. Okay, so now to generate that DC variable DC for the motor. Keep in mind this motor, this type of motor is a permanent magnet DC motor. It's excited by itself. So I have just to supply its rotor and its armature here, and it will rotate. Okay, and by rotating, it will rotate the generator with it. Coming back to how we can generate variable DC. So for the motor, we'll take our single phase, variable DC. So this is the auto transformer, single phase auto transformer. We excite, here we have two single phase rectifiers. You can use any one of them. So I'm going to use, for example, the first one here. Okay, so I'm going to supply my rectifier this side and getting the DC variable because the AC itself it's a variable here using this knob. Okay, 0 to maximum to back to 0. And here we're going to supply our motor, but keep in mind the polarity, please. So plus minus with minus and plus with plus here. So this is step number 1. Okay, now right now we have excited our motor, supplied our motor. So as soon as we start our source, and we keep on varying here the voltage toward the toward the maximum, for example, the motor will rotate. So when we stop here, we stop when we reach the rated speed of the generator, of course. Okay, rated speed of generator. I have to double check exactly if it's 1975 or 1950 RPM. So this will be given precisely to you after. This once you excite your motor, okay, you supply this motor to this variable DC here. You have to keep your eye on the tachometer, either fixed or portable one. Once you reach this one or that one, indicates the rated speed, you have to stop varying the voltage here, and you have every time you have to watch the speed. Keep in mind this is a motor. As soon as we excite our winding after, this will be seen as a load for our motor, mechanical load for the motor. So this will slow down as soon as we increase the excitation. This will be heavier for the motor, so the motor will slow down. So each time before you take the data, you have to double check the speed. The speed should be kept, as I told you, constant. If you see that the speed went a little bit down, you have to increase the voltage a little bit here to bring it back to this rated speed. So each time you have to double check before you take the data, which are the generated voltage across the armature and the current, the excited current for the field current. You have to double check the speed. If the speed went down, put it back, increase it a little bit until you reach the rated value, and that time you can take the indicated value of the voltage and the current after. So this is the first step to be done, is in terms of connection. So you connect your rectifier, you supplied by this single phase auto transformer. The variable DC will be connected to our motor. Going back now to this generator, how we can excite the generator? Look, we have two elements here: the field winding and the armature. So those are the terminals that will be used, okay? The field and the armature. This is shunt. This shunt here for the if we use this one as a motor and we use a shunt motor, so we have to put these ones here in parallel. For our case, we will be using this one as a generator because this machine, it's compound machine, so it can be used as a generator or motor. For our case, we'll be using it here as a DC generator. So we have its armature here and the field winding. Now let's supply the field winding by variable DC. So variable DC, now since we have used this one here, let's use a DC that three-phase rectifier, and you supply three-phase rectifier by three-phase variable three-phase voltage. So keep in mind this is a fixed three-phase supply, okay, from here to here. That's the fixed one, and here which is a variable three-phase supply. This auto transformer, three-phase auto transformer. So we take our fixed voltage and we pass it to our variable auto transformer. Okay, so line one to line 1, 2, and 2, 3, and 3, and we okay we receive our variable three phase the other side. So let's supply our variable our sorry three phase rectifier, as you can see. Okay, so those are three phase voltage or voltages, so they'll be connecting this they'll be supplying this three phase rectifier, and the other side will let's change the color here just to make it more clear for us. We'll change the color here to red one. Okay, so now here we're going to excite by through ammeter. So we need our ammeter to be in the path. We take our plus, going to our, let's say for example, this is our ammeter. Okay, we can connect it in milliamp or amp, depends. So let's start with milliamp. If the current they are a little bit bigger, we can change it back to amp connection. So this is our ammeter. So this will indicate IF, and the COM here will be going toward our field winding. Now the field winding, the other side, will be going back to our minus supply, minus DC. So like this is number one. Okay, going to our ammeter, going back, coming back to our winding, and going back to our supply, like that. So now we excited our field current, field winding, sorry. So by varying this knob here, three-phase voltage, we're going to vary the IF from 0 toward the maximum, where we can reach the saturated voltage. Okay, so this is number one. Now we have to record or monitor the generated voltage. So these two terminals, those are the outputs of our generator, will be connected to our voltmeter. So this is like that. Okay, so now we can record our IF and record our EA. Okay, so we can record many data. So minimum, as according to our experiment today, minimum 11 points. Okay, to plot our graph. Okay, once we reach saturation here, we go back, we reduce now. So this knob here to keep one more time. So this, let's say I'm going to write it here, to keep constant speed, and this one here, okay, to vary the field current. Okay, so we reach maximum, we go back towards zero to plot the other part of our characteristic like this. Okay, so this is our should come in from this point here. Let's change the color to show you the other one. So for example, if I take this color here, so from here, sorry, it's hard. I'm going to do it the other way. Yeah, so from here, we'll go back to our 0 IF. So that's the characteristic, and this is how we can use our sun station. Now, if you need to use this variable, that this fixed tachometer, okay, the way to connect that one, look, we have to supply it. So to supply this one, we need 12 volts. So we take our red and ground here. So there's this red and black. So this red one, we can use either from generator or the motor. Let's take from the generator. So this will be connected to red here to supply our our tachometer, and ground to the ground here. Okay, and the input here, which is the speed itself. So speed, take another color. Okay, so the speed will be connected from here to here. That's the input, and this is the ground. You can ground it directly from here. So jumper from ground to ground. So now we supplied our tachometer, okay, via the generator itself, and we're reading those are like what you call sensors inside this generator. So here we'll be displaying the speed of our system, of our generator. Assalamu alaikum, and welcome back again. I'm going to continue explaining how we can record the magnetization characteristic using this the feedback station. Okay, I already explained the sun station, how can be connected. Now feedback station will be used to explain this experiment for that part of the video, my second part. So for this station here, we have few equipment to be used. We have the motor, DC shunt motor. Okay, so we need our DC motor. Okay, shunt means we have to take the winding with the armature should be shunted, should be put in parallel. So we have jumper to be used, okay, to connect the armature and the field, and this winding here to be connected in parallel and supplied by DC voltage, variable DC voltage. So we need variable DC voltage. This is number one. Number two, we need our DC motor, and this DC motor and generator, they are mechanically coupled. So we need the DC generator. This is the core and the main part of our experiment. And this DC generator has armature and field winding. Okay, so that's the third equipment. The other equipment, since we don't have two variable DCs in our or two variable DC supplies in our station. We have only one, so we'll be using one variable DC to to connect our motor or supply our motor to make the speed variant. And for the other one, since we have a fixed DC, we'll be supplying this field winding through a rheostat. Okay, rheostat which will make DC fixed transferred to variable DC. Okay, so this will be shown in my explanation shortly. So this is a rheostat. So for variable DC, so this is the part number 4. Of course, we need a meter and voltmeter to record IF and EA. Okay, so those, let's say, for example, this is the fifth equipment and the last equipment here, number 6. Okay, now let's go to next page where we have all equipment, physical equipments. Okay, a photo of the physical equipment, sorry. Now we have, as I told you, we have variable DC here, and we have fixed DC to be used from this supply part. Okay, now let's connect our variable DC to the motor here. Of course, we have, that's the DC motor, DC shunt motor. So this is our motor, and this will be our compound machine, which is the generator, DC generator. Okay, we'll be using tachometer, portable one, and the 2 multimeters, one as a meter, the other one voltmeter, and rheostat where you can make the DC variable DC. And this is like a view, side view for our coupled machines, and you can see the mechanical coupling, okay, done using this part here, this mechanical parts to connect the motor and generator together. So once we excite the motor and we change the speed of the motor, this will follow, will be carried by this rotor here. So that rotor will be rotating the other rotor, and the generator will follow in terms of speed. They will be having the same speed. So this tachometer can be either connected or put here, or the other side. We have access to both axes. Now the rotor for this motor and the rotor of the generator will have access from both sides, so we can measure the speed. Okay, either this side or the other side. They have the same speed since they are. There is no reducer. There is nothing. This is a direct mechanical coupling. So the speed here will be equal to the speed of that generator. Okay, now coming back here, how we can connect our equipment. As I told you, this is the motor, and we have to, first of all, we have to make shunt motor. Means we have to make like 2 jumpers, one up and one down. Okay, to make this, maybe I can remove this one here just to make it more clear. So this is our motor. So by putting 2 jumpers up and down, okay, between the winding and the armature here, please don't make it from across the armature or the winding. By doing it across one of them, we're shortening that part. So up and down 2 jumpers. So by doing this, as I told you, we'll make a DC shunt motor. Okay, shunt means parallel like that, and we supply them with a variable DC. So one will come here, and the other one, let's say, for example, will come the other side here. So this is variable DC supply. Okay. Now, this DC supply will be varying using this knob here, this one. Now, let's make the other DC, fixed DC, we'll make it variable. So we'll take the plus of that DC fixed supply, we'll connect to the upper connector here for this rheostat, and the minus to the minus here. Okay, not the ground. Okay, this part. Okay, these two, they are not connected. If you connect your minus to the yellow one, okay, your supply will be floating. There is no coming back path for the current. So this will be supplying our input for the rheostat, and the output. Okay, different color will make it more clear. Just close this pane. Okay, so the output, this is input, this is in. The out will be this side, this is out. So the output with the ground, okay, input and output, they have the same ground. They will share the same ground. So this will be going, of course, through the ammeter. Let's continue like this. Say, for example, this is the ammeter. Okay, and coming back from the ammeter from COM here, be coming back to supply our field winding. Okay, and now the ground will be, that part will be, sorry, this part here is overcome this wire, and this will be supplying the minus here, the negative pole or terminal of our winding. Okay, so the current will come from out here, will go through the ammeter, come back from the ammeter to the winding, and from the winding will close the loop and going back to our ground here. Okay, so now as soon as we use this knob here to vary this fixed DC, okay, the current here, this is the IF, and will be displayed by this ammeter. So that IF will be changing. Now we have to record EA, okay, the generated voltage across the armature of this generator. So okay, the plus will be going to plus here, and COM, okay, will be going toward minus here. That's it. So few equipment, few wires. We can use using this feedback station, okay, to record our feedback, sorry, okay, to record our magnetization characteristic. Okay, so same thing. Now we go forward, okay, from 0 toward a maximum for each same thing for each data. Before you take it and record it, you have to check the speed. Okay, that speed should be all the time kept constant. Okay, so if it's reduced, you have to increase it from here, and after that you can take the recording of IF and EA. Okay, and we do this for different for many points, going forward and coming backward like this. Okay, using this one going back from handle, going back to now to 0. Keep in mind this go forward and backward. Once we reach forward, the maximum of the forward, we finish that experiment. Don't switch off. Don't turn off. Don't slow down your speed of the motor. You keep it constant all the time. So you finish forward with the same speed, the same equipment, the same setup. You go backward again. Okay, there's no stop station in here. I mean, stop points. or stop phase. We have to continue running our machine forward and backward. Once we reach zero, that time we can stop our setup, our machine. To conclude our both recorded videos and explanation for this this experiment, let's summarize what you have to do. Let's summarize through procedures. Okay, from steps from one to six, as you can see in this page. So once you connect your setup, either the SAN, okay, or feedback, stations. At that time, what you have to do, you have to start by changing the speed of the motor itself. Okay, so varying the DC for both stations, SAN or feedback, varying the DC till we reach the nominal speed or rated speed of each station. So for SAN, we have to reach 1500 RPM, and for feedback, it is a very big speed. So let's reduce it to 2500 RPM. So we vary our supply till we reach 2500 RPM. This is for feedback station, the white ones, and for the black stations, the sun stations. Once we reach 1500, 1500 RPM, we stop there. And after that, we keep those both stations at those speed, fixed ones, and the constant speed. Now from the generator side, we excite. Okay, we have to excite our generator. Okay, so we have to use the other variable DC. And you remember we used a rectifier for a SAN station to make variable DC, and rheostat for our feedback station. So we use both of those variable DC to increase the voltage DC. By increasing the DC voltage, we can vary the field current, okay, and the field winding for both generators, SAN and feedback generator. Okay, now we keep increasing this field current till we reach 120% of the rated value of each one of them. So, okay, according to the nameplate for each one of the generators, for the SAN generator, okay, the nominal value of the voltage is 190 volts DC. That's the rated voltage. So we have to add the 20% to that. So 20% will be around 38. So plus 38 voltage DC. So this will be around 228 volt DC to be reached for this sun station. And we assume that when we reach that value, we'll be reaching that saturation section from our magnetization characteristic. And keep in mind for both the cases, both stations will have to keep the speed constant for all measurements. So as I told you, before you record any data, you have to check that speed for SAN is 1500 and for feedback is 2500 RPM. Now coming back to our rated value here for feedback station. So generator, the voltage, rated voltage for the generator is 220 volts DC. So if we need to add 20%, this will be 44 DC, volt DC. So adding to this will be 264 volt DC to reach the saturation, okay, part of our curve. Okay, so now once we reach those both 120% for the rated voltages for both stations, Okay, by keeping all the time our eye on the speed for both stations. We go back, okay, towards zero and record again IF and EA, and all the time we have to check the speed. And once it's done, so this from step number 1 to step number 4 will be done with recording all data needed to plot our magnetization characteristic. For steps 5 and 6, this is another characteristic which we have to plot. This is step 5, sorry, steps 5 and 6, where we have to plot, okay, or check the behavior of generated voltage across the armature of the generator versus the speed. Let's say N has a speed, okay, in RPM. Okay, so what you have to do, we have just to excite our generator till we reach the rated voltages for both stations, which are 190 and 220 for feedback, 190 for sine and 220 for feedback. So increase the current till we reach that one. The speed is zero, of course. Okay, the speed should be kept zero at the beginning. We have just to reach that point and start from the point where we have, let's say, sorry, this point here. This is 190 for sun and 220 volts, 20 volts for feedback. We start from that point, and we start varying the speed of our systems from 20% of the rated speed till the 100% of the rated speed. So if we calculate those speeds, so for sun, 20% will be 300 RPM, and for feedback will be around 500 RPM. So from 300 toward 1500 RPM, and 500 toward 2500 RPM. Okay, this is for sun, and this one for feedback stations. Okay, and same philosophy, we have to keep our eye now on the current, because we fixed the current here before we change the speed. So for each point, okay, we have to check before we take those 2 points, EA and speed. We have to check the current should be all the time fixed. If it goes high or low, we have to bring it back or put it back to the rated value where we have rated voltage. So I think once we're done, you'll check that you see that the voltage will be going something like small. Sorry, it's one line, but with the angle going down a little bit. So this will be recorded and checked. Okay, this part here. Okay, so this is just to summarize what you have to do once you connect our both stations, and from where to start and what to take, what to keep constant, and when to stop. Okay, thank you, and good luck in this experiment.